Hello everyone. The topic that we will be discussing is on neutral point. So earlier we have learned that depending upon the sign of source charge or charge, the electric field lines of forces change its direction. If the charge is plus Q, the electric field lines of force is readily outward, and if the source charge is minus Q, the electric field lines of force is readily inward. Readily inward. So in order to understand the concept of neutral point, let us consider two charges of the same strength. Say here it is plus Q, another charge is also plus Q. So the direction of the electric field is like this, this, like this. So on the midway between plus Q at A, see this is A, point A, and plus Q at B, there exists one point, say N. If we place a test charge at this point, it will not experience any force. It will not experience any force. So this point is called a neutral point. The question may arise, what will happen to the position of this neutral point if we change the magnitude of these two charges? For example, if we have here is plus Q and another charge, say it is plus 4Q. So the direction of electric field is like this. And plus 4Q is like this. So now we will find where is the position of the neutral point. So we don't know. First of all, we don't know where is the position of neutral point. So let us consider somewhere here N is the neutral point. Somewhere here that this point is neutral point. So here A and here this point B. So if we place a charge here, it will not experience any force. So now what is electric field at N due to a charge plus Q at A? It is 1 by 4 pi epsilon naught. Charge is Q divided by AN square. And the electric field at N due to a charge plus 4Q at B is 1 by 4 pi epsilon naught plus 4Q divided by Bn square. So since the test charge at N will not experience any force, so the electric field E and A is equal to E and B. This equation and this equation, they are equal. 1 by 4 pi epsilon naught, 1 by 4 pi epsilon naught will get cancelled. So we can write Q divided by AN whole square equal 4Q divided by Bn whole square. So QQ will get cancelled. If we transfer this Bn, so we'll get 4 AN square. So what is Bn? Bn is nothing but root over 4 of AN. So we can write Bn is equal twice of AN. So if the distance of a point N from A is x, what is the distance of a point B from N? It is 2x. So clearly from here we can see that the position of the neutral point will shift towards the smaller charge. So the question will arise, is the equilibrium of the test charge is stable? Is the equilibrium of the test charge placed at N is stable? So let us discuss. What does it mean? Is the equilibrium of the test charge placed at N is stable? What does it mean? Suppose if a test charge experience a restoring force in all directions, then the equilibrium of the test charge at N is stable. Or else, if otherwise, then it is not stable or unstable. So let us consider this one to be plus Q, this one to be here also plus Q. So this is a point, say A, and this point is B. So the electric field lines of force is like this. Like this. This is, since they are of the same strength, so the neutral point is on the midway between these two charges. So N. So let us put a test charge here. First of all, let us consider that this test charge is shift towards the right or little bit shift towards the left. What will happen? This test charge, if we shift towards the right, it will experience a force, and that force will bring back this test charge Q0 at N. Again, if we shift this test charge toward the left, it will experience a force, and the force will bring back this Q0 to N, to this neutral point. So what will happen? What we can see from here? So if we move this test charge either toward the right or toward the left, it will experience a restoring force. However, if we move this test charge little bit above, then it will experience a force, and that force will take away that Q0 far away from, it will take away this Q0 from N. And if we move the test charge little bit downward, it will experience a force, and that force will take away this test charge away from this point. So what we can see from here is that if Q0 is shift little bit toward, is shift little bit above or below, it will not experience any restoring force. So since this test charge do not experience a restoring force in all direction, it experiences a restoring force in this and in this, but not in this direction. Along horizontal, it experiences a restoring force, but along the vertical, it does not experience any restoring force. So thus we can say that the equilibrium of the test charge is unstable.